This is worksheet 8-9, problem number 3. It reads, a 100-gram sample of radioactive isotope is taken from a protective container. After 4 hours, the sample decays to 85 grams. What is the half-life of the substance? So we're trying to figure out the half-life of this substance. So let's just kind of plan it out, look and see what we've got. We know that we've got a 100-gram sample that we're starting out with. So we know at the start of time here, we've got 100 grams. And then it says after 4 hours, it has decayed to 85 grams. So after 4 hours, we're at 85 grams. Okay, so we haven't even made it one half-life. We know that one half-life would take us all the way down to 50 grams. So what we're going to need to do, just like the last problem, right, we are going to have to figure out what our value of K is. So we should be starting to feel comfortable with this process, right? We're going to use these values. This would be our A naught, right, because that's the value we're starting with. This is going to be our new amount, right, so we'll call that A. And then this is our time unit, right, so this is time. So we're going to use all three of these to find what K is. So let's plug them in. We've got 85 is equal to 100 times E raised to the power of K times 4. And then we will just take it and use our calculator to solve and find this value. Let's go ahead and pull it out. Let's go to y equals. We're just going to type it in as 100 times e raised to the power of 4x. And then we're going to subtract 85. So we graph it. All right, we can already see there is our x-intercept. So let's go ahead and figure out what that is. Our value of k in this problem should be about negative 0.0406297. Right, I'm going to leave it at that. That should be close enough to get us a fairly accurate answer. So our next step then is going to be to figure out what the half-life is going to be. Right, so our new equation that we have, A is equal to 100 times E raised to the power of this number. So we have negative 0.0406297 times our time. Okay, so what is the half-life of the substance? What do you think you need to do with this equation to figure out the half-life? Well, remember the half-life is a time. So we're going to be finding this time, and we're going to need to plug in half of what we started with for our A value. So we'll say 50 is equal to 100. Actually, I wrote that a little too high. Let me move that down for a sec. There we go. So 50 is equal to 100 times E raised to that power of negative 0.0406297 T. Right, and then just subtract your 50 and then be ready to solve it on the calculator. And here we go. Go in, clear it out. We have 100 times E raised to the power of negative 0.04, not 5, 6297. We'll call it X on there, and then we'll arrow down and put minus 50. Okay, so we graph it, and you can see that it is going down until we get to 17.060. So T is going to be approximately 17.060. Now, what are we talking about? Well, we said we were talking about hours up here, so that'd be 17.060 hours. And that is our answer.